So machines within virtual networks are automatically going to be able to communicate with one another, all right? And they'll also be able to communicate with the internet by default. So there's absolutely nothing that you need to do save a valid IP and subnet configuration to make that happen. But what about other virtual networks? What about on-premise networks? Well, we are going to need to do something to get connected to those. Okay, now there technically are three options. You have VNet peering, which is probably the simplest and quickest way to connect virtual networks because it just kind of happens pretty seamlessly. But that really only applies to Azure VNets. We have VPN gateways and ExpressRoute, and that's going to apply to connecting to an on-premise environment. And they're going to differ in their capabilities and cost and things like that. Now that we're actually going to talk about in more detail in a different topic. So in this topic, we're really going to just focus here on VNet peering. So VNet peering, as we said, is very simple and easy. It seamlessly connects to Azure Virtual Networks. So once you have peered the VNets, they appear as one for at least connectivity purposes. There are two major types. We have regional VNet peering, which connects VNets in the same region, and then we have global VNet peering, which can connect virtual networks in different regions. They can technically, I mean, when you do the global peering, the VNets can exist in any public cloud region, including China cloud regions, but they cannot exist in the government cloud regions. So anytime you're using the government cloud regions, you would only be able to peer with another VNet in that government cloud. So two basic types. Some benefits that we have to either of those kinds is that the network traffic is always private. Between the VNets, it's kept on the Microsoft backbone, so it does not go over the public internet. There are no gateways. There's not even encryption that's required because it's all private traffic. Very high performance, low latency, high bandwidth. Seamless communication, the abilities for resources in one VNet to communicate with resources in another very, very easily within a region, across regions, technically across Azure subscriptions if you want. And a gateway can provide access to additional remote networks. Okay, so when you peer the virtual networks, what you're going to end up doing is setting up a VPN gateway as a transit point. So the two peered virtual networks will use that gateway and the gateway network to communicate with one another. And I can then use that same gateway to extend and use a site-to-site VPN or a point-to-site VPN to connect for a client. There are a few options that we get when we go to configure VNet peering, and there are a couple of other things for us to talk about, but we're going to do that as we walk through a demonstration. All right, in this demonstration, we're going to just show what happens when we've got a couple of virtual machines that are in two different virtual networks in terms of their ability to communicate with one another, and then we're going to remedy that situation with VNet peering. Okay, so we've got here two virtual machines. The second one I just created, so I've got Win10 and Win10.2. I am actually connected to both of these virtual machines in a remote desktop connection. So this is Win10 number 1, and if I do my IP config, I can see I'm 172.16.0.4 with a gateway of 0.1. I can then see that I am able to communicate with the internet. However, I can then see that I am unable to ping the machine on the other network. Okay. Now, to see that that is the machine on the other network, let me flip between those two. I gave this one a different background just to help myself out a little bit, but this is 172.18.1.4 there. So you've got two machines sitting on two separate virtual networks that are in the same resource group. So we're actually going to go in here and we're going to look and see that this Win10.2 is PL Test VNet 2. And then the first one is just the PL Test VNet. okay, and the default subnet. So they're both in the same resource group, but technically on two different virtual networks and obviously two different subnets. And now we can see that they are unable to communicate with one another. So again, how do we remedy that? And as we've been discussing, the easiest way to remedy that is to do peering, to actually get to the virtual network. So let's go there. So we're going to PL Test VNet, and then within the settings, right under DNS servers, we've got peerings. And we just click the add button to add a peering to get started. Okay, and then you can specify the link name. Now in production environments, we want it to be somewhat logical. Okay, so we'll just call this the PL Test VNet link. I've only got two. The traffic to the remote network, do we want to allow? That's the default setting. Or we want to block all traffic. Traffic forwarded from the remote network, allow or block. Do we want to use a remote gateway? Okay, we can check whether or not we want to do that. Do you want to use the remote virtual networks gateway or route server? None by default. That means that the only reason that this peering would be used would be to communicate between the two VNets. You want the individual resources on each VNet to use their own gateway. Okay, and then the peering link name. And the deployment model, and we can choose the resource or the classic model. We do want to select the virtual network that I am connecting to, which in this case would be VNet 2. All right, let's go up here and check. Okay. And then we have the same settings. Do we want to allow traffic to and from? And then I have a different setting for the network gateway. But then we just go ahead and click add. And this is why this is considered the easiest, is because it literally is just going to kind of peer those two networks. You should now be able to ping. They're going to be connected. So let's go back to and just view our virtual networks. And let's search via the resource group. Oh, you know what? That just took me to that group. That's not what I want to do. The problem is we just have so many of them, so I'm going to group them by resource group. There we go. So now within PL Test, we've got the PL Test VNet, PL Test VNet 2. Okay, those are the ones that exist within that resource group. And looks like I need to clean some of this up. But those are the two. So now let's go back here and see what happens. Can we now ping between those two? Now we may not be able to because I may need to make sure that the firewall is actually allowing that. Let's go to that firewall. I'm just going to turn it off. So we'll go in here and go to the properties and turn it off just to ensure that is not causing us a problem. Private off and public off. Okay, hit OK. Now that's this machine. Let's just check to make sure I'm on the right one. So I'm on 16.04, and I'm going to switch remote desktop windows here. And now I can get a response. Okay, the firewall's off. So I would have to do the same thing on this one, turn the firewall off. We can hop over to the other one, and we can see that that communication is now working. Okay, if I trace the route, it looks like it's just going directly, but it doesn't even show me the hops, which is a little bit strange. But you have two virtual networks within the same resource group, within the same region, and you've peered them together, so it connects them as if they were on the same network and provides communication between those two networks. All right, so that's going to complete the demonstration, kind of short and sweet, but it shows how we can simply and easily connect virtual networks in Azure. We're going to look at securing virtual networks, making sure that we have control over the traffic that is allowed in and out of a VNet and to and from the machines that are hosted within that VNet. Just as this is important in an on-premise network, it certainly is as important in the Azure cloud. There are different options that exist for securing traffic to and from VNets. Most of us are immediately think of, if we're thinking on-premise, we're thinking, well, packet filters on router interfaces. or potentially switch interfaces, right? And then firewalls. And firewalls can be software, host-based firewalls that exist on the machine, like Windows Server, Windows 10, or a third-party kind of network firewall. In Azure, we don't call everything the same thing, and these are not necessarily synonymous with one another. But network security groups is sort of like the packet filters on a router, okay? In that network security groups are going to be applied to virtual network interfaces, which are then used by the client, okay? So it's not a host-based firewall because it's actually at the network level, and it's doing input-output filtering as to what ports and source IP, destination IPs are allowed, but it's assigned to the network interface. The Azure Firewall is an actual firewall appliance. It's a managed cloud-based security service that protects the VNet. And it's got several features and benefits. So that would be like a network firewall. And then you also have third-party virtual appliances. So you don't have to use the Azure firewall. You could use any of the third-party options that are available. So we'll start with the NSG. The NSG is going to be acting as a network level firewall for specific virtual network adapters. NSGs can also be assigned to entire subnets to create a protected subnet, sometimes often referred to as a DMZ. NSGs have the ability to limit the specific traffic that flows to and from these resources. It's going to be pretty straightforward when you get in. I mean, we have inbound rules and we have outbound rules. They can be assigned to one or more subnets. They can be assigned to one or more network interfaces. And that's just going to depend on your particular planning and your needs. So if I created a subnet that's going to have all of my servers on it and I want to restrict traffic, I would probably create an NSG specifically for that subnet. You know, if I just want a standard default NSG for all my VMs, then just create one or modify an existing one with what you need, and then utilize that. So NSGs are a compilation of rules, and the rules are going to be applied to virtual NICs and to subnets to filter the traffic that's allowed. There are several rules that are created for each NSG by default. Inbound and outbound rules of basically allow any to the virtual network inbound, load balancer one that's created. We'll see these when we create one, and then you can go and create as many additional rules as you want. And just like any other packet filters or firewall rules, you're going to get the same features. You know, we're going to give it a name. We're going to specify the port it applies to, the protocol, TCP, UDP, or any source IP addresses, destination IP addresses. Those can be subnets. Those can be specific addresses, and then the actual action, whether it's going to allow or deny the traffic that matches this rule. And the rules are evaluated in the order of the subnet is greater than the NIC, basically. So the subnet rules would be evaluated for traffic entering the subnet before the rule would be evaluated for traffic entering a virtual NIC. That should make sense if we just think of logically how the traffic flows. There is an effective security rules tool that you can use to confirm whether a particular type of traffic is allowed or blocked, and it'll be showing you that. So essentially, we just need to get in and decide what traffic we want to allow and what, if any, we want to deny, and then create NSGs and assign them as appropriate. In this demonstration, we're going to look at creating network security group rules and how you can use those as sort of a network-based firewall, but one that is actually attached to either VNets or individual network interfaces, okay? The easiest way to get to this is to actually go to the networking interface, say for a virtual machine. Although again, we can do it at the VNet level, and I'll show you how to do that. When we get to a VM like Windows 10 here, and then we go to networking, we see over here the network interface. And you also do see like effective security rules, and technically directly beneath that, you are seeing the network security group. So it says network security group Win10 NSG is attached to this interface. It impacts 0 subnets and 1 network interface. So this is solely for this machine. And that's going to be the default. but it's probably not the most efficient, right? The most efficient is to, in general, we would create NSGs that would be applied to a particular subnet. But, again, for demo purposes, we can technically do it anywhere. So once we get into the NSG, then in the settings, we're going to have inbound security rules and outbound security rules. Okay. Underneath there, network interfaces shows the interfaces it's associated with. Subnets would show the subnets it's associated with. So let's just go here, inbound security rules. Notice VNet inbound. If the source is the virtual network, it's allowing any source, any protocol, any port, as long as it's internal. Same thing with load balancers. And then you have this catch-all at the end that's saying it's going to deny anything that's still there that hasn't matched, it's going to deny. Okay. Now we have RDP, and when you create an individual virtual machine, by default, it's going to open up the RDP port. That typically is just for, that is just for you to initially connect to that machine to be able to manage it. However, that should not be left that way. We really never want to have RDP open on any system, albeit that it, might be okay if it's a non-production system, you're just kind of playing around like in our case. But if it's tied in any way to Azure AD or an on-prem Active Directory or anything of that nature, this is definitely not something we want to leave. So what would we do if we wanted to be able to access this? Okay. What I would probably do is I would just go and change the source. I can leave RDP open, but I want to change the source and say we're actually only going to allow this from, these particular address ranges. Okay. Now, I'm not going to do that here just because it'll terminate my connection. And again, this is a test environment, but we would put in either a single source IP address or we would put in a range of addresses. Okay. So for our company, for instance, we put in the range, it's not a huge range, but the range of addresses that are associated with our primary data center at our business. And so I know that I can RDP to these devices, but only if I'm either in a facility, okay, in one of our locations, or I have a VPN connection to one of our locations. So that secures it. All right. Please don't make the mistake of leaving these open. I've had clients make the mistake of leaving them open, and when they do, typically they get hacked, and typically it's ransomware, and it's nasty. So that's one of the leading causes for ransomware. One is compromised accounts due to lack of MFA, but the other is having RDP open to the internet. So don't do that. Yes, we need to be able to RDP to those devices. However, we really should lock down the source. And then, of course, you can add as many inbound security rules as you want. And it's the same, same syntax. We've got source, any, IP addresses. You do have service tags, application security groups that can be from within Azure. The source port ranges. Okay, so whatever we want to do. So I would say I'm going to allow 443 inbound, and it's going to be 443. Okay. And then you can just say it's TCP port 443 that's being allowed from any source. And technically, I know we're saying any destination. However, it's not any destination because it is just this system, right? So in doing so now, I've actually said to allow port 443 to that particular machine. Okay. We'd have to get out of the virtual machine to test that, but again, it's an allow or a deny. I mean, that's really all it is. Now you can create separate network security groups. If you just type in network security groups, it's going to bring up the list. I can create a new NSG. We can, just like with everything else, specify the resource group that it's going to be in and the name. Okay, so subnet 1 NSG, for instance. We'll go ahead and create that. Now, all this is a network security group. Until it's associated with network interfaces or associated with subnets, it's not doing anything. But visibly it's going to look the same. I'm going to go to inbound security rules. I'm going to see all the defaults. I won't see the RDP one. Okay. And so then I can go in and I can add individual rules.